Okay, so we'll be starting 9.7 trigonometric identities. So in the previous class, we learned sine square x plus cos square x equals to 1. Okay, sine square x plus cos square x equals to 1. So this is called a trigonometric identity. Okay, because it is true for all values of x. Right now, right, one of the possible questions for your IG also is that we will be proving, okay, we'll be proving using trigo identities. Okay, so far, right, what we have learned from the previous class, sine square x plus cos square x equals to 1. The next one that we learned was tangent x equals to sine x over cos x. Okay, so this for the part 9.7. Later on, we'll learn another 2 or 3 more. Okay, and then you all will learn the inverse of sine, cos, and tangent also. Okay, so let's look at work example 15. Work example 15. All right, so prove the identity 1 plus sine x square plus 1 minus sine x square plus 2 cos square x equals to 4. Okay, they are asking you to prove the identity. Okay, the keyword is proof. So they are not asking you to solve the question. When they say prove the identity or prove the equation that this left-hand side is equals to the right-hand side, you just need to take one side of the equation to prove to the other side of the equation. Okay, not solve. Solve means you need to find the value of x. They're not asking you to solve here. Okay, so how do you do this, right? Same thing in life. We normally take something that's complicated to make it something simple. Okay, you want to take something complicated. Let's say it's like this. This is a complicated one to something simple. So you never want to take something simple to make it complicated, because it'll be very hard and it's not good lah, right? Logically also it's not good. So if you look at this equation, we call this left-hand side. This is right-hand side. So you'll see the word LHS and RHS. Okay, so if you look on this equation, the left-hand side looks more complicated, right? Right, so much longer. Then after that, we want to prove that it's equal to 4. Okay, so you take the left-hand side. So you start from the left-hand side. You just write LHS. Then you write down the equation. Okay, our goal, right, is that we want to simplify the entire equation to make it equals to the right-hand side, which is equals to 4. Okay, that's the answer that we want, 4. Okay, there are probably different possible answers also, but the one that they want right now is equals to 4. Okay, so right now when you see this, right, you might not be able to see it yet. I also cannot see it yet. So you need to slowly expand it and then use this trigo identity that's above. What you have learned so far is sine square x plus cos square x equals to 1 and tangent x equals to sine x over cos x. Probably you will need to use that to simplify your equation. Okay, so you keep that in mind. Later on, we'll learn even further, so more complex one. So 1 plus sine x is actually 1 plus sine x square is a plus b square, right? So you can write it as 1 plus 2 sine x plus sine square x. This will be your first one. Second one, a minus b square can be written as 1 minus 2 sine x plus sine square x. Okay, maybe I put it like this, then you are clear. Purple. Okay, so this is the second term, how we expand. Then plus 2 cos square x, we can just leave it. Okay, whenever you all see cos square x, sine square x, all this, right, what should come in your mind is this sine square x plus cos square x equals to 1. So this trigo identity, keep it in your head because it will be useful for you to solve trigo kind of equations. Okay, so you see, right, Okay, let's simplify the entire equation first. Whatever that we can join together, we join together. So 1 and 1. Let's see some more. Got anything more? Plus 2 sine x and minus 2 sine x. Right? Then sine square x and sine square x. Okay, then 2 cos square x by itself. Okay, so let's join it together. The yellow one, 1 plus 1 will become 2. Second one, plus 2 sine x minus 2 sine x, so that becomes 0. Sine square x plus sine square x become 2 sine square x. Then the last one, plus 2 cos square x. Okay, so you see right here, there's a 2 sine square x plus 2 cos square x. Remember your trigo identity, what I just mentioned just now? Sine square x plus cos square x equals to 1. So the question to ask is that, can I simplify this 2 sine square x plus 2 cos square x to become sine square x plus cos square x? Can, right? All you need to do is you factorize it. Okay, so you factorize 2 out so that we can cause a 2 sine square x plus cos square x to appear. Once we have this, then we can apply sine square x plus cos square x. It will be equals to 1. So you see, 2 plus 2, then your final answer is 4. Can you see? Now it's equals to the right-hand side, right? So if you want to write complete, you can write equals to RHS. So this is proven. So we are just trying to prove that left-hand side is equals to right-hand side. Okay, you can take right-hand side equals to left-hand side also. It all depends on the equation. There's no fixed formula to always start from the left-hand side. Okay, let's move on to the second one. Work example 16. So they say prove the identity 1 over cos x minus cos x equals to sine x tangent x. Okay. So this one, both also look a bit complex, but I think I'll use the left-hand side to start. So left-hand side is equals to 1 over cos x minus cos x. So remember, your goal is that you want to try to change it to sine x tangent x. Okay, sine x times tangent x. So what you can keep in mind right now, okay, now you observe the equation. 1 over cos x minus cos x. What can I do? You want, now there are 2 terms, right? 1 over cos is one term, then minus cos is the second term. But if you look at sine x tangent x, is one term only. Okay, sine times tan. So maybe what we can do is to make it into the same denominator so that we can join both of it together. So what would happen? I want to make both to your denominator cos x. So 1 over cos x. Here multiply cos x over cos x. So this will be cos square x over cos x. Can see? Okay. Sometimes you have to try and error. There's no fixed formula for this. You just need to apply your trigo identity. And I might do it differently. You might do it differently also. Okay, in terms of the steps. But eventually the proof, your result will be the same. Okay, so now we can join it together. 1 minus cos square x over cos x. Okay, so whenever you see sine square or cos square, just a reminder again, you should think about sine square x plus cos square x equals to 1. You can move around also on the equation. So sine square x plus cos square x is equals to 1, right? Can I maybe replace the 1 minus cos square x with something? So if we just shift around, we put the cos square x to the right-hand side. Now can you see? 1 minus cos square x is actually sine square x. So I can write it as sine square x over cos x. Okay, so we are almost there already. Sine square x over cos x is good. Why? Because tangent. So you need to observe your right-hand side also. Tangent, right? So sometimes you can work both ways also. Tangent is sine over cos. Can I make a sine over cos appear here? Sine square x over cos square x? I can, right? Okay, I separate. Okay, let's separate the sine square x to sine x times sine x. So it can be sine x times sine x over cos x. With that, I can write sine x, sine over cos is tangent x. Okay, and you see it's equals to right hand side, therefore proven. Okay, so this is one of the possible question that will come up in your exam also. Okay, one of the possible. Okay, later there are a few more trigo identity that we need to know. But there are 3 trigo identities that will be given to you in your formula sheet. That means in your exam, the page 2, they will give you sine square x plus cos square x equals to 1. Then they'll give you another 2 more. Okay, so you can actually derive from there. In the case that you forgot the identity, you can always refer to that. Okay, let's move to 9.8. 9.8. Further trigo equations. Okay, so solving of equations, right? Solving of the trigo equations, when they say solve, it means finding the x value. Okay, there's another 3 more trigo that we'll be learning right now. Cosecant theta, secant theta, and cotangent theta. Okay, cosecant theta is 1 over sine theta. Secant theta is 1 over cos theta. Cotangent theta is 1 over tangent theta, or cos over sine theta also can, because tangent theta is sine over cos, right? So you terbalik it will be cos over sine. Okay, so these are another 3 more that you have to memorize. Okay, it's just in the inverse of it lah. So how I remember, right? Cotangent, you see got the T lah. So cotangent means tangent, 1 over tangent. Okay, the short form is cot theta. Cot theta. Okay, so 1 over tangent. Normally, students get confused between the cosecant and secant. Okay, how I see, right? I memorize from the secant theta. So secant theta, you terbalik it. So you SEC, then you read it backwards. C, but you replace the E with O. So COS, cos theta. Okay? So you inverse the equation. How you read it, also you inverse it. Okay, so then the last one, cosecant theta, will be 1 over sine theta. Okay? So, okay. Then after that, there's another, so in terms of the identities, so just now I mentioned that there are 3 trigo identity that you need to know. We learned so far is sine square theta plus cos square theta equals to 1. Okay, sine square theta plus cos square theta equals to 1. Okay, so you all go back, right? And then you all remember how we actually proved the sine square theta plus cos square theta equals to 1? It's actually through Pythagoras theorem with a right angle triangle. Okay, so the other 2 trigos okay, the other 2 trigos can also be proven it in that way. So we draw a right angle triangle. This is x, this is y, this is r, and this is your theta. Okay, so let's write out what is sine, cos, tangent, and then what is cosecant, secant, and cotangent. So sine theta is equals to y over r. Cos theta equals to x over r. This is it in reference to this right angle. Tangent theta equals to y over x. Okay, so we learned that cosecant theta is the inverse of sine theta, which is 1 over sine theta. So your value here will be r over y. Secant theta is the inverse of cos, so it will be r over x. And then cotangent theta is x over y. Okay, so now we got this few to work with already. Okay, using Pythagoras. Okay, using our best friend Pythagoras theorem, we can conclude that x squared plus y squared equals to r squared. Go back and refer to the previous lesson. How we prove sine squared theta plus cos squared theta is when we divide it by r squared to the entire equation. Okay, so that's the proof. If they ever ask you to prove the trigo identity, you use this. Okay, so now if we want to prove another identity, you divide the whole equation. Okay, divide the whole equation by x squared. Okay, you all try and see. Divide the whole equation by x squared. So how it will look like? X squared divided by x squared will become 1. Y squared divided by x squared will be y over x squared. R squared over x squared will be r over x squared. So now, right, what you want to do, you refer back to the identities, okay, that we have above. What is y over x? So you find, okay, so you'll see here, tangent theta, right? So it'll be 1 plus tangent, got a square, so tangent square theta equals to, okay, let's find another one. Where's r over x? Over here, secant theta. Okay, so it will be secant square theta. So this is another identity that we have. Okay, 1 plus tangent square theta equals to secant square theta. This will be given in your formula sheet, okay, in the page 2 in your exam. Okay, so there are 3 things that will be given. This is one of it. First one, sine square theta plus cos square theta equals to 1. Second one will be 1 plus tangent square theta equals to secant square theta. Okay, we want to prove one more identity using Pythagoras theorem again. Okay, so this is the, in a way, the second one out of the first one is sine square theta plus cos square theta equals to 1. So we use again Pythagoras theorem. So x squared plus y squared equals to r squared. This time we divide the whole equation by y squared. Okay, I want all of you to try before you all look at this. Okay, divide the whole equation by y squared. You all see what will you all get. Then use the identities above. Okay, your sine theta equals to y over r, cos theta equals to x over r, tangent theta equals to y over x, and so on and so forth. Okay, so you divide it by y squared. First term will be x over y squared. Y squared plus y squared divided by y squared will be 1. R divided by y squared will be r squared divided by y squared will be r over y squared. So go and see what is x over y. X over y. Yours refer to the list. Cotangent. Okay, cotangent. So cotangent square theta plus 1 equals to r over y. So what's r over y? So we find r over y here. Cosecant theta. So it will be cosecant square theta. And this will be your third trigo identity. Okay. Do you need to memorize this? In a way, yes and no. Okay, it'll be good if you memorize it. Then at least at the back of your head, you know that cotangent square theta, cosecant square theta got some relationship. Tangent square theta and secant square theta got some relationship, which is this trigo identity. Okay, but main one, you at least need to know sine square theta plus cos square theta equals to 1. Okay, then actually you can derive it from there. You all can go and try also, but for the sake of time, I won't show you all. Another way to prove it is that you just take from sine square theta plus cos square theta equals to 1. Then you divide the whole equation by sine square theta. You'll get one of these here. Okay, you'll get one of these here. Then another time, you divide the whole equation by cos square theta. Okay, so one is divided by sine square theta, one is divided by cos square theta. Okay, let's move on to work example 17. Work example 17. Okay, solve. So you all see here the word solve. They're not asking you to prove anymore. Solve 2 cosecant square x plus cot x minus 8 equals to 0 for 0 degrees to 360 degrees. Okay, so now you see it looks a little more complex already, right? But don't worry, it's doable. Okay, you all see, right? Now I want you all observe the equation. There's 2 cosecant square x, then there's cot, and then there's this 8 lah. Whenever normally when you solve trigo kind of problems, right, you want to make the entire equation to one trigo only. You want to try your best to make it to one trigo. Otherwise, you have to factorize it. Okay, if you cannot factorize it, then you have to make it all to one trigo only. It's either sine, cos, tangent, or cosecant, secant, cotangent. Okay, so you keep that in mind. Make it all. Make the equation to just one trigo. And this is not mentioned in the textbook, so you might want to write this down. Then you at least know how to solve it. Okay. So when you see cosecant square, any trigo with a square, right, you would want to think about the trigo identity, one of the trees. Okay, so just now what we learned, there's one, right, that gives you cosecant square, which is cotangent square theta. Okay, maybe I write it in red. Yeah. Cotangent square theta plus 1 equals to cosecant square theta. Okay, the theta, right, you can write anything inside one. It can be x, it can be y, it can be 2x, it can be 3x, but it needs to be the same. Okay, all the theta needs to be the same. Okay, now you see, right, do I want to change cosecant square to cotangent square plus 1? The answer is yes, it's good, right? Because over here, I have a cotangent. So remember the goal is that I want to make the equation to all one trigo. This is when you want to solve your equation. So let's change that to cosecant square x, right? It can be written as cotangent square x plus 1. Can you all see that? Okay, so I replace this with this. Then cot x minus 8 equals to 0. Let's expand the bracket. 2 cot square x plus 2 plus cot x minus 8 equals to 0. If you all observe, this is actually a quadratic equation. So you get 2 cot square x plus cot x minus 6 equals to 0. Okay? Got it until here? So you see, right? Now you simplify it to a quadratic equation already. So you can use the let method here. Okay, if you want to use the let method, it will be let cot x equals to u. Otherwise, if you can see and you can factorize it, you don't have to make it to let method. Okay, but yeah, if you want to simplify it, you can write it to like that. 2u plus u minus 6 equals to 0. Go and factorize it. You'll get 2u minus 3u plus 2 equals to 0, where u is equals to 3 over 2 and u is equals to negative 2. Okay, change it back to cotangent. So cot x equals to 3 over 2. Cot x equals to negative 2. So you see, now there are two possible values. Okay, but remember the solving kind of question, you are supposed to use the ASTC graph. ASTC doesn't have cotangent, cosecant, and secant. So what you want to change is that if you have cotangent, cosecant, or secant, change it back to sine, cos, tangent. Okay? How to change it back? Cotangent is just 1 over tangent. So tangent x, okay, is actually 1 over tangent x. Okay, I just write lah. Okay, you don't have to write this line, but this is just an explanation. Equals to 3 over 2. If I want to find tangent x, you just inverse the other side. So that's why you see in your textbook, tangent x equals to 2 over 3. Same goes for this also. Tangent x equals to negative 2. Therefore, tangent x equals to negative 1 over 2. Let me move it. Eesh. Oh, yeah. Okay. So, do you still remember how to solve this? Tangent x equals to 2 over 3. Tangent x equals to negative half. I hope over the weekend you all have been trying this. Like what I said, if you all don't practice, everything is linked together. Okay? So, how to do this? First step, find your base angle. Okay, so find your alpha. Alpha, then you'll use your calculator in terms of degrees. So shift tangent bracket 2 over 3, you'll get 33.7 degrees. Okay, 33.7 degrees. After you find your base angle, you draw it out on your ASTC graph. Okay, draw it out. Okay, later we need this also, another one. Your tangent x value is positive, right? Equals to positive 2 over 3. So which quadrant is it at? ASTC, first and third. Okay, first and third. And then your alpha is towards the x-axis. For me to find angle that is in the first and third quadrant, this is theta is equals to alpha. This is theta is equals to 180 degrees plus alpha. Therefore, you find your x value, which is 33.7 degrees, and 180 plus 33.7 will be 213.7 degrees. Okay, so you got two answers here. Do the same thing for this value here. So tangent x equals to negative half. So go and find what's your alpha here. Shift tangent 1 over 2, you'll get 26.6 degrees. Your value is negative 1 over 2. So you use ASTC, your second quadrant and your fourth quadrant. Okay, your second quadrant and your fourth quadrant. So alpha and alpha here. if it's second and fourth quadrant, second quadrant, your theta will be 180 minus alpha. Fourth quadrant will be 360 minus alpha. Okay, then you find what is your angle. So your x is equals to 180 minus 26.6, which would be 153.4 degrees, and 360 minus 26.6, and you get 333.4 degrees. Therefore, you will get 4 answers. Okay, 33.7, 213.7, 153.4, and 333.4 degrees. So this is how you solve the equation. Sometimes, right, it might have 6 answers, 7 answers, 8 answers, and all also. Okay, it will come out in exam like this also. Okay, so if you haven't tried the basic solving one, please go and try it first, because otherwise this whole part here, you won't be able to do it. Okay, the only way is to figure out the beginner level one first. This is a bit more complex already, but it's actually the same exact concept. All right. Okay, let's move on to the very, very last example. 9.9. 9.9. Further trigo identities. Okay, so you see, right, in your exam, they will only ask you a certain type of question for trigo itself. Solving, which was what we did just now. Proving. Proving is the proof left-hand side equals to right-hand side. Okay, so this work example 18 will be the same as just now, the proving kind of question. So, work example 18, prove the identity. Okay, the question is prove the identity 1 plus secant x over tangent x plus sine x equals to cosecant x. All right, take the more complex side, simplify to the simpler side. Okay, I'll help you all with this. Later on, you all can go and try again. So sometimes you have to play around. Sometimes I, like at the first few steps also, I don't know what to do actually. So you just have to keep trying. Okay, keep trying, and then you want to try to make it to cosecant x. Cosecant x is also 1 over sine x. So technically, we want to prove this left-hand side to 1 over sine x. Okay, so let's take the left-hand side because it's a more complex one. 1 plus secant x over tangent x plus sine x. Okay, remember our goal is that we want to change it to 1 over sine x because that's cosecant x. So you see all this secant and all, then there's tangent. Okay, we can simplify it. So secant x can be written as 1 over cos x over tangent x sine x over cos x plus sine x. Okay, once again, there may be multiple methods that you can do to solve this question. Okay, so we want to simplify this entire thing. Okay, one of the things maybe we can do is on top we make it to 1 fraction, bottom we make it to 1 fraction. So on top, if I want to make it to just over cos x, so your denominator as cos x, so it'd be cos x plus 1 over cos x. The bottom, okay, the bottom will be, I also make it to cos x only, so it will be sine x plus sine x cos x over cos x. Can you see? Okay, so on top, make it to 1 fraction. At the bottom, make it to one fraction. Okay, this is good because now this and this can actually be cut with each other. Okay, if you all don't understand this, it's actually A over B divided by, let's say, C over D. Okay, it will be equals to A over B divided by C over D, which is A over B times C over D. Okay. Yeah. So this is the concept. If you're unsure, just write it down to this concept. Okay. Otherwise, you can actually just simplify the entire thing. And this would give you cos x plus 1 over sine x plus sine x cos x. Okay, you all see right over here, maybe cannot see it. Okay, but very close already. Okay, you can keep in mind this one over here is 1 over sine x. Okay, so now you have to see. Now at this step already, how can I simplify my entire equation to 1 over sine x? That's the question. All right, if you see on top, I want to make it to 1. So maybe at the bottom, can I make it to some cos x plus 1 also? Or 1 plus cos x? Can, right? You just need to factorize out sine x. Okay, factorize out sine x. So it'll be sine x 1 plus cos x. Okay, 1 plus cos x or cos x plus 1 is the same thing. This and this can cancel off with each other. Therefore, it'll be 1 over sine x, which is equals to 1 over, not 1 over, which is equals to cosecant x. This is equals to right hand side, therefore proven. Okay, so this is a proving kind of question. What I realized in exam also, many students struggle with this question. Okay, because there are so many possibilities. So sometimes what I advise students to do also is that you leave this question for later on. Like when you all finish the entire paper, only you all do this question. If you all keep getting stuck, but don't leave it empty. Okay, never ever leave it empty. Just try your best until, like, if you get stuck, also just leave it only. Okay, because last time when I was a student, I remember I'm very bad at this question. Very, very bad. So I always leave until the last question only I do. Okay, so this is actually the end of Trigo already. Let's do a short summary on what we have learned. Okay, summary. Okay, at the start, we learn what is positive and negative angles, okay, according to your ASTC graph. So if we have an ASTC graph, okay, let's draw this out. Going in the clockwise direction is equals to negative angle. Going in the anti-clockwise direction, anti-clockwise is positive. And here is we normally start here is 0 degrees. Okay, then we learn about ASTC. What's the meaning of ASTC? It is, we will be using this for solving your trigos. Okay, 0, then 90, 180, 270. ASTC, you can use the acronym or mnemonic, all students take care. In the textbook, it says all students trust Cambridge. Okay, brainwashing you. Okay, you all trust Cambridge, right? That's why you all only take IGCSE. Okay, so yeah, you all can remember it that way. ASTC. Propaganda. Okay, then the next thing that you all learn is the trigo identity. Okay, but maybe before we go to trigo identity, we learn cosecant theta is equals to 1 over sine theta. Secant theta is equals to 1 over cos theta. And then cotangent theta or cot theta is 1 over tangent theta. All right. And the very last thing, trigo identities. Okay, this will be given in your exam. I think except tangent x. Okay, so tangent x is equals to sine x over cos x. These other three, you all can just go and open your past year. You all can see this. Sine square x plus cos square x equals to 1. But if you want to memorize it also, in a way it's good lah. Then you all know how to actually apply it. So you don't have to keep on referring to it. Second one, 1 plus tangent square x equals to secant square x. The third one, 1 plus cotangent square x equals to cosecant square x. Okay, so the type of question that will come out in your exam is solving. Okay, solving. So solving, you need to use your ASTC. Okay, later on, Trigo also in the topic of differentiation, you all will be using it again. Okay. Then the next one is proving. Okay, proving. So you want to prove the left-hand side equals to the right-hand side. And then actually there's one more. Yeah, so we also learned about graph, right? So, okay, we don't have to write it here. But one more is, a possible question is the graph. Okay, graph of sine x, cos x, tangent x. So you all need to be very, very clear on how to sketch the graph and how the value of A, B, and C. There are three things that we learn. So A is your amplitude, B is your period, C is your vertical transition. Okay, whether you go up or go down. So these are the three possible questions you'll see in your past year question. All right, because once you're clear, right, exactly what kind of question that they will ask you, then at least you won't be so blur like, oh, which topic is it from? What type of question are they asking me? Okay, so I summarize, and because I've analyzed so many papers already, it's actually can be summarized into just these three questions. Yeah, but we don't talk about the other chapters. Later on, you will see some Trigo also. But based on Trigo, this particular Trigo chapter itself is actually just these three questions. Okay, so congratulations, you all have finished chapter 9.